Hello, this is AAT, section 4.4, Simplifying Radical Expressions. This is Mrs. Rich, and here we have, again, the rules, the exponent rules, because remember, a square root or cube root is just a type of exponent. It's a fractional exponent. Remember, when you have a fractional exponent, this is going to be the power divided by the root. And you can either, if you're trying to simplify something like this, you can think of this as x to the m first and then square root it or cube root it, whatever the root is, or you can root it and then do the exponent on the outside, which is nice. Either order works, so you can do whichever one's easiest. But we're going to start out simplifying square roots and cube roots, which you've done before. So remember, I rewrote this as -8, and I'm going to separate out the square root. So 24 is 4 times 6, and 4 is 2 times 2, and 6 is 3 times 2. So remember, we can only pull out of the root perfect squares. So if I write this down, 2 times 2 times 3 times 2, 2 times 2 times 3 times 2. Anything that's a perfect square, I'm going to be able to pull out. Now notice I have a k to the third also, which is k times k times k. So what comes out of the root? The square root of 4, that 2 times 2, can come out, and when it's square rooted, it becomes just a 2. So we got the -8 already out there. Now we have a 2. The 3 and 2 is going to stay in there. We have a pair of k's here. The square root of k squared is just a k. So that will come out. And then we have a k still in there. So what's still in there? A 3 times a 2 times a k. So now we're going to multiply everything up to clean it up a little bit. -8 times 2 is -16k. And then in the inside, 3 times 2 is 6k. And that's our simplified answer. Okay, so take a second and you try B. Okay, so now to check this one, the answer was 12xy root 2. Here, when I multiplied it down, notice I got 144 times 2, and as soon as I got a pair, 12 times 12, of course I could have taken this further down to 4 times 3 and 4 times 3, but as soon as you get a pair of things, you know 144 is a perfect square, so we can go ahead and know that we're going to pull out the 12, and the 2 will stay in. Now, I didn't write these out in factors this time, but I know the square root of x squared, you're just going to take half as many out. So now an x comes out, and half of y to the fourth, oh, that's a y squared. Okay, hopefully you noticed that. I forgot to put in y squared. So we're taking out half as many because the square root of 4y's would have been 2y's. Okay, C. So again, we have 6. 75 is 25 times 3, and as soon as I see there's a pair that's going to come out, a 5 will come out. 3 will stay in. M is an odd exponent, so that's going to have to stay inside. P to the second, 1p will come out, and q to the third, since that's q to the second times a q to the first, the q to the second will come out, and the q to the first will stay in. So we end up with a 5 coming out, a 3 stays in. So I'm going to leave a little space for my variables here. So a 3 stays in, m stays in, don't lose anything. P squared, square root of p squared is a p comes out, and square root of q to the third, a q comes out from the q squared, and a q stays in. Now I clean it up a little bit. 6 times 5 is 30, pq square root of 3mq. So when you finish, always look and make sure there's no perfect squares in here, nothing divisible by 4 or 16 or 25. And you should never have more than just something to the first in here as far as your variables, because if so, then there was more than could have come out. So that's our answer. Okay, this one's a cube root. So remember, on a cube root, only things can come out if there are 3 of them, because you are cube rooting them. So let's start with 125, is 5 times 25, or maybe you already knew that it is 5 to the third, 5 times 5 times 5. So I have 5 to the square root of 5 to the third, or 5 times 5 times 5, either way you want to write it. X to the fifth is 4 x's and 1 more left, and x as y to the ninth is 8 y's and 1 more y, and then we have a z. So I got a pair of 5's here, so 1 5 comes out, 1 5 stays in. I have x to the fourth, so that's x squared comes out. I'm going to half it when it comes out because you have half as many. But this x stays in. Y to the eighth, a y to the fourth comes out, but this y to the first stays in because it was originally to the ninth. And z, it's an odd exponent, so that z stays in. So that's one way to kind of do it. Write out your even exponents, so you take out half the exponent, half as many, because if we wrote all those out, there would be 4 of them, but only 2 come out. And then when you have those odd, those single ones, you know that they stay in. Double check your work as you go. Okay, now we're going to go to adding and subtracting. Simplify each of the following. So remember, you can add roots that have the same radicand. If the radicands are the same, then you can combine their like terms, and you can add or subtract their coefficients. So first we need to simplify. 20 is 4 times 5, which is 2 times 2 times 5. So these 2's come out. So I have that negative 3 root 5 plus a 2 root 5. Now, as long as these two roots are the same, which they are, it's just like a negative 3x plus a 2x. You can combine the like terms, which is negative 1x, or negative 1 root 5. So negative root 5. Negative 3 plus positive 2 is a negative 1, and then you keep that root 5. Okay, so same thing here. We're going to simplify them all first. 45 is 9 times 5, or 3 times 3 times 5. 20, we just did, is going to be 2 root 5. And 6 is 3 times 2. So on this one, I'm going to pull out the 3. When I pull it out, I got to multiply it by that negative 2. So what would that be? Negative 6 root 5. Pull out this 2, multiply it by that 3. Negative 6 root 5 again. Here, though, there's nothing paired, so that just stays a negative 2 root 6. Nothing to pull out on that one. So remember, we can only combine like terms, and like terms in this situation would be the same radicand. So negative 6 and negative 6 root 5 would be negative 12 root 5. And then you have minus 2 root 6. There we go. Cannot combine these unlike terms. Okay, C is a cube root, and again, you can only simplify cube roots if you have 3 things to pull out, but cube root, you can take the cube root of a negative number. So when you have a negative, the cube root of negative 1 is a negative 1. Negative 1 times negative 1 times negative 1 is negative 1. So I can pull out a negative out of a cube root or an odd root to the 5th, to the 7th. So I'm going to pull that negative out so I don't have to deal with it anymore in here. And I have a negative times a negative. I'm basically just pulling out a negative 1. So I have positive 3 now times the cube root of 3. 162, let's see, is, I'm going to start with 2 times 131. And 131 would be sorry about that, somebody was at the door. Okay, where was I? Whoops, that shouldn't be a 30. That would be 262. So 81, no, always making little mistakes. 81 times 2 would be 162. And 81 is remember, we can only pull things out if there are 3 of them. So we know 81 is 9 times 9, which is 3 times 3 and 3 times 3. So on this one, we have 2 times 3 times 3 times 3 times 3, 4 3s, and it's a cube root, so I can only pull out a group of 3. So I had a 2 outside already. The 2 and the 3 stay inside, and 1 3 comes out because this is a cube root. So 1 3 comes out, that makes it a 6. The 2 and the 3 stay in. So 6 cube root of 6. So we had 3 cube root of 3 plus 6 cube root of 6. And 81, we just did 81, is 9 times 9, which we found was 3 times 3 times 3 times 3. So again, we can only pull out a triple because this is a cube root. So this is going to come out and tag up with that 3 on the outside. So we'll have 9 on the outside and a cube root of 3 left on the inside. Okay, so can we still do anything with this? Well, we can combine them if they are like terms, and they are. This 3 root 3 and this 9 times the cube root of 3 we can combine, which is 12 cube root 3. Combine those coefficients, and the 6 cube root of 6 stays separate because it is an unlike term. Okay, so I'm going to give you a second, pause it here, and give number 6. Okay, so here this is the answer to D. 5 times the cube root of 6 minus 7 root 6. This one's a little tricky, a little confusing because you have cube roots and square roots, and they both have these 6's in them. But I started out by simplifying this square root of 24. 24 is 6 times 4, so it's 2 times 2 times 6. 2 times 2 times 2 times 3. So a pair comes out. You notice I started out pulling out 3 things because I was used to simplifying square roots, cube roots. So be careful. That's a square root. So a pair of 2's come out, multiplied by the 3, and that becomes 6 root 6. So I'm going to combine the cube roots. 2 and 3 would be 5 cube root of 6. And negative 6 and negative root 6 and negative 6 root 6 would be negative 7 root 6. Remember, there's a little 1 in front of that. So that's a tricky one. Okay, so we're going to stop right there and then continue on the next page with the next video.